present a small research about ecological alternative for air-water heat pump. We did in our Technical University of Civil Engineering Faculty of Building Services in Romania, and also with the support of Romanian General Association of Refrigeration. This work... Yes, okay, it's better, thank you. This work we did together with a group of PhD students and master students, and I want to thank them and to present first steps of our research. As we know, we discussed a lot about legislation, protocols, Montreal protocols, Kyoto protocols, but in our country we can discuss about EU legislation because we are EU members. So we have to respect now EU regulations, and one of these is very important, this F-gas regulation. So we have to replace our refrigerants in our systems with ecological refrigerants, and we are talking first of all about natural refrigerants. Romania is a natural refrigerant user, traditional user, and used a lot ammonia, and now is working in supermarkets with CO2, and we are using also hydrocarbons. But in research we don't have enough results about olefins. So we try in this small research to discuss about replacement of 134A with an olefin. But also we make a comparison with 8 refrigerants. The comparative study of these facilities followed the coefficient of performance and also total equivalent warming impact in respect with standard 378. And as we know, energy efficiency is directly related to global warming and greenhouse gases emissions. You can see here the heat pump. There are a lot of information about this. I don't want to lose time with this. We have in this area the compressors with evaporator and also expansion valve. We have here in this area the condensers, and there are other facilities. We can also use solar collectors and electrical resistance to offer support for when we need. Also, you have some data here about this heat pump, and more detailed you will see in my article. In this table, we make a comparison with Coolpack software between 6 refrigerants, 134A, the refrigerant we try to replace, and the other HFC, and also with a hydrocarbon. And for this point of view, we see that the best coefficient of performance is in this area for our isobutane and 152A. You have some data about pressures and also about global warming potential and ozone depletion potential in this table. As we see, the best also again there are hydrocarbons. We made also some comparisons because, as I told you, we didn't use yet olefin in our research laboratory with 3 types of olefins you have here in the tables, and we see for this heat pump the results using Genetron software for cooling COP and heating COP, energy efficiency ratio in fact, and as we see the best is the olefin 1234YF. For the point of view of cooling COP and also for heating. Here you have the technical drawing. It's a very simple system with only one compressor, one condenser, one evaporator. And you have also here expansion device. And we used also other software. And you have here in this furnished some data from the comparison between the olefin and 134A and also 152. And as we see, the best is from the point of view of pressure is 1234 YF in comparison temperature versus pressure. The program used, the software was RefProp. We have also, after we simulate some data with RefProp regarding temperature versus density for this 4 type of refrigerant. And as I told you, we use Genetron Woodpack on RefProp for calculating and analyzing the energy efficiency for this heat pump, and to make comparison between different ecological characteristics, we calculate the total equivalent warming impact using the formula for standard 378 and the methods of calculation of the standard. The leakage of refrigerant was 8% with a recovery factor of 0.75, and the operating time was about 15 years, and CO2 emissions was for Romania 0.37 kilograms per kilowatt hour. You have in this table the comparison between total equivalent warming impact for these 8 types of refrigerants. And we can see here that the best was isobutane, R600A, and immediately we have the olefin R1234YF. Also you have data about contribution direct and indirect, because in the calculation total equivalent warming impact has these 2 components, and we can see here again the advantage, finally advantage of hydrocarbons and olefin. In conclusion, in this paper, we analyze, we calculate energy efficiency and also ecological efficiency for 8 types of refrigerants. We use many types of simulations and softwares, and you have here Woodpack, Genetron, and also RefProp. We can say for energy efficiency point of view that the most advantageous was 1234YF with a COP of 0.498, and for environmental point of view was the hydrocarbon, the isobutane, with a total equivalent burning impact of 8.99 tons of CO2. And the next refrigerant, the difference is very small. As you see, it's 8.992, and here is 8.995 tons of CO2 is for olefin 1234YF. Because we have to decide finally the optimum, the eco-efficiency, the most eco-efficient refrigerant, we decided, and it appears that 1234YF remains on this moment the most advantageous as far as total equivalent warming impact is concerned. This is a first step. Now we will try to make experiments, and our research will continue. And next time we will present in the next KDH our results. I want to say thank you for inviting us here. We are a group from Romania, and for Technical University of Civil Engineering, we are a group. And also thanks to the organizer and to the Presidium for helping us. Thank you very much. And if you have any questions, don't hesitate to ask me or to send me an email. You have here all the data. Thank you very much.